Hey coders, how's it going, guys? So I came across this question. It looks like an interviewee at Facebook got this question, from Meta, whereby um, they were required to design a data structure that support insert, delete, search, and get a random value in constant time. So we will see how we can actually go about this. Uh, so because they say that we have to delete and search, right, and insert an element and also get a random value in constant time, right? So these operations should be done in O of 1. Okay, so a hash map can actually get us halfway through. So we know that given a value x equals to 13, we can probably get it in O of 1, and we can delete it. We can search this in hash map. You can just say given a value x, you can just take the hash and say x, and this you're gonna get it in constant time because the value has been hashed, so it's gonna retrieve it. Okay, even insert, we can insert in constant time, but now, like getting a random value, this can be tricky. So let me show you this. Let's say we have a hash and we know that our values are the keys, right? And we have a value here, right? So if we have to search for the key, we have to search on the key, because of that's how we can insert, search, and delete in constant time. But now some of you might be like, okay, we can get the range, right? Let's say this hash was probably 14 and started at 0. That's the length of this hash. And some of you might be like, okay, we can get the length of this hash. Then what we can do is that we can pick randomly between 0 and 14. Let's say we pick 6. Then we say, okay, that's a random number. Then we go and search in the hash map, and we get the element. But the problem with that approach is that the keys here, these keys have elements, meaning that they can range from, they are not necessarily indices, meaning that you can have 40, you can have 100, you can have 50. So now if you're gonna go with this approach, it's like you're using indices. So you're not gonna be able to search. For example, let's say you got 6, but these are your elements, then you're not going to be able to retrieve that value. So how can we then design this in such a way that we get a random value in constant time? We can use an array, right? We can use an array in such a way that we can also append all of these elements inside an array. So all of these elements that go inside a hash, like we spoke about, 50, 40, and 100, etc., we can actually append them at the end of an array. At the same time, we're appending them inside a hash. So why do we need an array is that we can have these indices. For example, we have 0, 1, 2, 3, and stuff like that. So every time we append an element, let's say we appended a new element is at index 4, we can say this index is going to become our value. And this has very advantage, because for example, let's say we want to retrieve an element, we can say from 0 to 1, given the range of the array, we can select any element, which can be 2, and this will actually help us to retrieve a value in the array in constant time. So I'll actually show you in code and how we can go about this. If you're still confused, don't worry, everything will be clear, because I will explain everything in much detail in the code. Okay, cool. So we're gonna design our data structure. So we're gonna call it DS, data structure constant, probably not the best name, but yeah. So what we need to do is that we need to initialize all the data structures that we're gonna need. So I'm gonna say self, whereby we're gonna say we need an array, and the only thing that isn't we need an array is because of that, whereby we need to get the random value. So we're gonna need a hash map, which is going to be a Python dictionary. So the first function that we're gonna start with is gonna be an insert. So let's just try to write at the high level what we need to do with the insert. The first thing that I can think of here is that we need to check. So we're gonna say check if the value x it exists, because you want to insert something that does not exist, right? If the x exists, then just return, right? That's the first thing that we can do, because it exists, so we don't want to insert something that exists unless we are told. Then what we need to do is that we need to, because now we know that the value does not exist because we did that check, is that we need to insert it into an array. So by insert, I mean we append at the end, right? But when we append at the end, we also need the index, so we can always get the index. Remember that all of these operations, and the reason we're doing this way, we also want to make sure that these operations are done in O of 1. So we don't, as I code through, I will show you, but you will understand. But the code here is that we want to make sure that everything is constant. So we append at the end, and we get the index at the end after adding that that value there. So in the hash map, we're gonna add the x. We're gonna add the value. Then the value is going to be the index that we retrieved from there. Okay, so that's the function that we show right now. So it's gonna be def insert. It's gonna take self because we need those data structures, and we're gonna take x that we need to add. Then we said the first thing that we do is to check if x in the hash map. So we're gonna say self.hash map. We have to then return if this is the case. I want to make sure that you understand that if I say x in self hash map, this is still constant. So don't get confused and think, oh man, I'm using in. So what happened with the hash map is that each and every value get hashed, meaning that it getting hashed, then we look at it by using a get function. That's what is happening underneath. So this is x in is not going to search every element. No, it's still going to be a constant operation. Okay, then we know that the value does not exist because we did search. We just need to append it at the end of the array. So we can say self dot array dot append. I'm gonna say append x. Then after we append, we need to get the length of the array. But I think let's get the length before, because of, you know, when you get the length, because of we starting at 0 with Python. So I think let's get the length first. So we're gonna say length. So I'm just gonna call it index. Okay, then we get the length of the self dot array, and this should work fine. But now we have the index, so we have the value. That we can do, we can just take the hash map, and we can say hash map hash map. Then we can take x, and we can say equals to the index. So this way. And in case you're wondering why we taking x and we're making it a key, it's because we can, when we're given an x, when we go into search, remember that they're going to give us an x, like the value, then we can be able to search in constant time. So hence here we hash the value is going to be the key, then the index is going to be the value, if that makes sense. Okay, so now we're going to design the remove function. So let's start with remove before we go to search. So let's say we're given an element, so we want to remove it. So to remove an element, the first thing that you want to do is that you want to check if that element exists, so that you can remove all the necessary bugs that can occur, because you might want to remove something that doesn't exist. But as we remove, we want to also remove in the array. So it's important that we remove from both the data structures. So I can literally do the same thing as I did here, but the problem with this is that when I search an element and to search if it exists, the problem is that it does not necessarily give me an index. So what I can do is that I want that index, which is the value in this case. So we can say index, we can use a get function, and we can say self.hash hash map dot get, which is actually going to give me that value, which is going to be an index for our array. So we can say none if that does not exist. Then what we can do is that we can say if index is equals to none, then we can actually return. Okay, so that's like checking. So we know that this index exists, and we know that this value exists. And what we can do is we can do remove the index, remove the value from the hash map. So we can say hash map, then we just want to delete the x, but this is going to be a self sort of that, and this operation is also constant, so it's just going to remove it just like that. But now we want to remove an element from an array. So removing an element from an array in constant time, it can be quite hacky, but how can we think about this? Let's say we have an array 1 2 3 4 5, right? So we have functions in Python such as a.pop, which can remove elements in constant time. We can remove an element, we can get an element at the end and remove it with something like this. This is going to give us a last element. But all of these functions that I'm showing you now, they are all operations that work when elements are at the end or in the beginning. But what if this index that we got, right, it's something that lies in between? And to remove it, honestly, you can just search through, right? You can just search through the elements and remove it. But then that is going to give you an O of n. So it's going to give you an linear time, which is against the data structure that we're trying to design. So we don't want that. So how can we do this? So given this array, what we can do is that we can then swap the elements. For example, we can take, let's say we wanted to delete 2. There's an example. We can just take 5 and put it where 2 is, and we can bring 2 to 5. And this is also a constant operation. So it's going to be, because we're just swapping elements, just swapping 2 elements, so it's also constant. So it's going to be of 1. So now that 2 is at the end, the value that we want to delete, we can just do the same thing that we did here and say delete from that. It's going to be constant. So what I'm saying is that we can get the length of the array because we want the element at the end. So we're going to say self.array, and we can say length of that self.array, and this is going to give us the length. Then what we're going to do is that we want that element, so we're going to call it the last element in this case. Then we can say self dot array, then we can actually say length, because of length is going to give us a length without taking consideration of the 0. We know when we index we start from 0, so we just need to say -1. This is what we need, right? But now we have an index for the value that we want to remove. We have an index for the value at the end. What we left to do is just to swap them. So how can we do that? In Python, we can just do it in one-liner, self.array, and we can say self.array, we can say length, -1, take the length, the value at the end, and swap it with self.array, and it's gonna be index, I think. Yes. And what next is to swap elements in Python. You can just do it this way, and it's gonna be in constant also. Okay. Okay, cool. You have that. What you have to do now is that you just need to delete this element. We had 2 here, and we just need to remove it just like that. So how can we do that? So we're going to use this function, which is called delete, and we're going to say self.array, and we have the last element, so we can say -1. It's fine. Okay. What's the last thing that we need to do? I think we have removed this. We just need to then update our hash. Okay, because remember that we took the last element and we gave it this index, so we need to change it then and give it the right index, so to speak, in the hash map. So we're gonna say self.hash map. We're gonna take, because of hash map we index in value, which means that we're gonna provide the last. That's why I save it here. Then we're gonna say equals to which is the index of the value that we wanted to delete. I don't know if that makes sense. Okay, so initially last value had this length, or this index, but now we're updating it to take the index of the array that we deleted of 2, right? That's what we're doing. So that's the remove, and that's the only complicated thing. I think the upcoming functions are going to be straightforward. The last 2 functions are actually going to be straightforward. The first one is going to be search. So we're just going to search this element, and we can do it also in one line because we don't have to check if the element exists. Mainly because we're using this function in Python. I meant to say the get function. So we can say hashmap.get x. If it does not exist, just return none. So it's very helpful. So the last one is also going to be one liner, which is a random. So I think a random, we're just going to say return self. So there's multiple ways you can go about this. So one way it is that you can actually use the random function, which I imported already. So the random function, you can use the function called choice. And don't forget that the only reason why we had to do all of these other complicated functions, it was because of it was going to be hard for us to get a random value from a hash because of the keys were the values. So now to get a random value, it's going to be straightforward because you've won, let's say this is your array 1 2 3 4 5, something like that, right? So what end up happening is that you can say random choice and it's going to give you a random value from here. But with the hash map, because of now, even if you use the length, it was going to be tricky because you can't necessarily get the random value because those were the keys are the values themselves. Anyway, I hope you understood that, and maybe it was not unclear. So you can just use random.choice and you can say self.array, and this will do it. Another way you can do it probably is to use the random.range. So what you do with this one is that you can take the zeros element and take the length of the array. Then this is going to give you a random value from that range. Then you use that element to query the array, then you get that element. So yeah, that's another way you can go about it. But yeah, that will do it, guys. This is the algorithm. I have tested it with different cases. It works. So I'll post it on GitHub so that you can also try it out. See you in the next video. Thanks. Bye.